and we're going to work through these together. Okay, the first question that we have this evening gives us in the diagram ABCD is a parallelogram. Let's just move it down a little bit. The diagonals of ABCD intersect at M. F is a point on AD such that AF is to FD is 4:3. And they've told us E is a point on AM such that EF is parallel to BD. And FC and MD intersect in G. All right, so what we can definitely do is put our ratio AF is to FD is 4:3. We can definitely put that onto the diagram. And of course, we can see here we've got a line drawn parallel to the third side of a triangle. So it would be possible for us to work inside triangle AMD and apply the proportionality intercept theorem. So let's just have a look at the first question. So it says calculate giving reasons the ratio of EM over AM. So EM is this bit over here and AM would be the whole thing. So could anybody tell me, sorry, in 1.1, what would EM over AM be equal to? What would EM over AM be equal to? Okay, so Ntokozo says FD over AD. Good. And Lebogang, you're also saying FD over AD. Quite right. So it would be equal to FD over AD. Well done. And our reason for that is proportionality intercept theorem. And of course, we need to name the parallel lines. So we've got EF parallel to MD. All right, so that means now we can go ahead and go and sub in. So EM over AM is going to be equal to FD will be equal to 3 and AD would be equal to 7. All right, so here there would be a mark on what it's equal to. Our reason, don't forget the parallel lines when you use proportionality intercept theorem, and then on our answer. Okay. All right, let's have a look at question 1.2 now. Here they want CM over ME. So I'm just going to highlight that for you. Here is CM. And here is ME. What do we think now? CM over ME. What would we do here? Can we apply the proportionality intercept theorem in this question? What do you guys think? Do we have a line drawn parallel to the third side of a triangle that we can work in? Or are we going to have to do something else? Yeah, well, this is a bit more of a thinking question. Okay, so Lebogang, you've said FG over GC. FG over GC. So you would be forgiven for saying that, Lebogang. You're not wrong. You are right. But why is that not going to work in this case? Why can we not work with FG over GC? So the reason we can't work with FG over GC is, yeah, we've got no ratios, exactly, intercausal. We've got no ratios. We've got no information about those lines whatsoever. Okay, so this is one of those things where, what you've thought of isn't wrong, it's correct, but it doesn't lead you to a solution. Okay, because there are no ratios. So we don't know anything about it's not that we don't know anything about FG, we specifically don't know anything about GC. There's no ratios there, so we need to think of something else. So what they want us to do in this particular question is they want us to go back to this idea that ABCD is a parallelogram. And this is where our properties of these four-sided shapes are so important. AM and MC are equal to each other. Why? Why does AM equal MC? Exactly, Tristan. Okay, so the diagonals of a parallelogram bisect each other. So our reason here is the diagonals of a palm bisect each other. That's it, intercausal. You're quite right. Okay, so we're actually nearly there with our answer. So that means that CM over ME is going to be 7 over 3. Okay, so here the marks are for AM equals MC, the diagonals for palm bisect, and then for your answer. Is everybody happy with that? Yes, okay. All right, thanks Tristan, thanks Lebogang. Let's go on and have a look at the next question. So we're going to highlight these triangles so we can see what we're talking about. So they're saying the area of FDC. So let's highlight that in a different color. Let's get green. So FDC is this triangle over here. Okay, that's the green one. And let's get another different color over here. Let's get blue. And we'll do the area of triangle BDC in a different color. So they share a side over there. And that. So we're focusing now specifically on the two triangles that I've highlighted on the screen, the green one and the blue one. So when they ask us a question like this, where they want the area of one triangle over the area of another triangle, we've got to think about how we would calculate the area of a triangle, right? So either we've got two ways that we can do it. Half base times height, perpendicular height, or we can use the area rule. So now we need to eliminate one of those possibilities because they're not both possible. What isn't going to work here? Could we use half base times height, or could we use the area rule? Okay, so Tristan says the area rule. If we use the area rule, okay, Lebogang also says we've got to use the area rule. If we use the area rule, then we have to have an angle that is in both triangles. Otherwise, we can't eliminate it. All right. So which angle is in both triangles? Is there one? Is there an angle that is in triangle FDC that's also in BDC? The answer to that, unfortunately, is no. Yeah, quite right. Okay, now angle C, Lebogang, part of angle C is in triangle FDC, but it's not the whole angle. So we haven't got an angle that's in both triangles that is the same. Right, so they also share part of D, don't they? Right, but there's no angle that's inside another triangle entirely. It's either a part of it or not there at all. Okay, so unfortunately, in this case, the area rule is not going to work. And I mean, somebody did say that a little while ago. Eliminate the area rule said into causal. You're quite right. And Tsechofatso is saying use base times height. Absolutely, half base times height. So that's correct here, right? We've got to use half base times height. Now, the reason why we're using half base times height is because there is a special property that triangles drawn between parallel lines share. What is that special property? If triangles are drawn between the same parallel lines, they have the same what? That's it, Ntokozo. They share a height. That's it, Tristan. Yes, they have the same perpendicular height. Okay, so that's something that we are supposed to know. It's one of the things that we would have had to learn. All right, they have the same perpendicular height because the distance, the height of both triangles, the perpendicular height of both triangles is the perpendicular line between AD and BC. That's the perpendicular height of both triangles. I don't know if that's obvious to you, if you can understand what I'm saying. Does that make sense? So any perpendicular drawn between AD and BC represents the perpendicular height of both triangles. Okay, all right. So let's talk about triangle FDC first of all, right? So at the top, we're going to write half times its base, right? So its base would be FD times the perpendicular height. Then as far as triangle BDC is concerned, that's also half base. The base would be BC and the perpendicular height would be the same. Okay, now we can eliminate. So, sorry, I should have written here, this is area of triangle FDC over area of triangle BDC is equal to, and now we can say anything divided by itself is 1, anything divided by itself is 1. So that leaves us with FD over BC. We know that FD is 3 and BC is going to be one of the sides of the parallelogram. BC is equal to AD. Okay, so BC is equal to AD because of the opposite sides of a parallelogram are equal. Okay, so therefore BC will be 7. Does that make sense? That's it. Good, Tsechofatso, that's perfect. All right, well done. Okay, so here there would have to be a mark for the opposite sides of the palm are equal. There has to be a mark on our answer. There has to be a mark for using half base times height and for getting our FD over BC. Is everybody happy with that? Yes, good. All right, lovely, well done. Okay, let's move on to the next question. Okay, let me just, what's that? Just, there we go. Just move this over a little bit, and then hopefully we can pop these questions in over here. All right, so obviously our mark allocation is important. We're looking at that all the time. So here, the first thing that they want us to do is write down with reasons 3 other angles each equal to x. But before we do that, let's read the information that's given to us. So this comes out of a 2019 NSC exam. It says to us in the diagram, ST and VT are tangents to the circle at S and V respectively. So what do you immediately think of when you read that information? What are you thinking of if we've been given 2 tangents, ST and VT? What do you think about? Aha, tangents from the same point, absolutely. Bohlale, yes, with pleasure, no problem. Go for it, Bohlale, there you go. Just quickly take a screenshot. That's it, Tristan. ST equals VT because they are tangents from the same point. Okay, I'm going back. Buklali, I hope you got the pick. And we must have, if they've told us tangents, we probably also have tan chord theorem going on here. So tangents from the same point and tan chord theorem is another thing that we need to think of. Then they tell us that R is a point on the circle and W is a point on chord RS such that WT is parallel to RV. So straight away, when they give us parallel lines, we start thinking about the kinds of angles we could get from parallel lines. We could get alternate co-interior or corresponding. And of course, if we've got parallel lines and we've got a triangle, we could also potentially use the proportionality intercept theorem in our answer as well. So we're linking to all those things. Then it says SV and WV are drawn, fine. WT intersects SV at K, also fine. Those 2 sentences don't directly link to any theorems that we know. And the last bit of information they're telling us is that angle S2 is equal to X. So we can see that angle S2 is an angle between a tangent and a chord. All right, and right when they say to us, write down with reason 3 other angles each equal to X, looking at the diagram, what angles do you think S2 is also equal to? What do you guys see? What would S be equal to? S2, sorry, exactly. Okay. All right. So Tristan is saying, okay. Yes, Tegofatso, that's correct. Why, Tristan, why will W2 not work just yet? It won't work just yet. K4, why K4, Rosaria? Why V2, Lebogang? Yes, into causal, that's correct. Okay, so into causal and Tsegofatso, you've both said things that are true. Okay, so Tsegofatso said angle R will be equal to X because of tan chord theorem. Can everybody else see that? The angle between the tangent and the chord is equal to the angle in the alternate segment, so that would be R. Then into causal said angle V3. So this is X. This would also be X. So let's just get that down. So here what we would do is you would say TS equals TV because they are tangents from the same point. So that means that V3 is also equal to X because they are angles opposite equal sides. Okay, so now we've got R3, we've got, R, we've got V3, we need one more angle. I know Tsegofatso said something. Okay, Tsegofatso, no, unfortunately it's not W2. Ah, that's better. Okay, so Tsegofatso said the correct angle now. Let's just see if everybody else finds that angle. We need a third angle, guys. Look at the diagram and see what else could be equal to X. You're very close into causal, but it does not include W2. Okay, it's just W3. I don't know if the rest of you can see this. It's funny, in matric, it becomes quite difficult to see these things. But here, guys, is your transversal. There is a parallel line. There is a parallel line. Now that I've done that, can you see that W3 and R are corresponding? Can you see that they're corresponding angles? Is that easy to see now? Oh, there we go. I know it's always difficult in matric Lebogang to spot corresponding angles. It's never as straightforward as it was when we were in grade 8, 9, 10, 11. Okay, they're a little bit more hidden. All right, so W3 is the third one. That's equal to X because of corresponding angles, and that's because WT is parallel to RV. So this was out of 6. So what they would be doing here is statement reason. Okay, you must include this TS equals TV, tangents from the same point, and then statement reason, statement reason. Okay, and remember, with corresponding alternate, co-interior, and proportionality intercept theorem, we have to name the parallel lines. Okay, they are strict about that, so please don't forget to include those in your solutions. All right, so there we go. 3 angles, each equal to X as well. So that's 1.1. Now let's focus on 1.2. The first thing that they want us to do is prove that WSTV is cyclic. Now they're always going to give you a quad and ask you to prove that it's cyclic. Sometimes it can be quite difficult. Other times it can actually be fairly straightforward and quite easy. So when we look at the mark allocation here and we see that it's out of 2, it can't be that difficult. Right, so let's go back and go and have a look. Maybe we've proved it already. Let's look at the diagram. Have we proved it already that it is a cyclic quad? So WSTV, that's it, so good. Well done. Let's just see what everybody else says. Sorry, I'm just rubbing that off. We've got an X here and we've got an X here. Can anybody else see what proves it? So those of us that are struggling, the minute that we see that there is a bow tie inside the cyclic quad, we're going to start considering converse angles in the same segment. If you put your fingers, and I know it's difficult for you because you're working digitally at the moment, but put your fingers at S and T. And then follow S to W and T to W. We've got angle W3. Go back to S and to T, and now come to V3. Can you see that they're both equal to X? So fingers at S and T, W3, and V3. Can you see they're both equal to X? You see it now? Okay. All right. So sometimes things are right in front of us and we don't even see them. Hey, it's the same for me sometimes too. Okay, so that would be our reason. So we would say that W3 equals V3 because they both equal X. Okay, and we've got that up here. We've got that V3 and W3 are both equal to X. So therefore, we can say that WSTV is cyclic, and our reason in this case is converse angles in the same segment. All right, and the reason that it's out of 2 is for this statement here, the angles that prove it, and the correct reason. Okay, so Tsehufatso, when you use equal chords subtend equal angles, that's like angles in the same segment, except the chords have been separated. So in other words, if you had, let's just scooch over to the side here. Let's say you had a circle. Let me just draw a circle for you quickly, and then you can see what I mean by this. Okay, that'll do. Okay, so imagine now you have a chord here and you have another chord over there, but these chords are equal in length. And this chord subtends that angle at the circle, and this chord subtends that angle, that angle at the circle, then these angles here will be equal to one another. That's equal chords subtend equal angles. Okay, so it's a corollary of angles in the same segment. All right, is everybody happy with what we have done so far? Okay. Yes, we're all good. All right. So now let's get into the slightly more difficult questions. So in part B, they ask us to prove the triangle WRV is isosceles. So let's just highlight the triangle. WRV is this triangle over here that I'm highlighting in blue. And how do we prove that a triangle is isosceles? What are the properties of an isosceles triangle? So when they ask us to prove that a triangle is isosceles, what are they actually asking us to show? With which triangle, Tristan? Kalipa, you're on the right. You got the right idea. Absolutely. So equal sides. How many equal sides? Yes, Lebogang, 2 angles. That's it. So if we want to prove, good, well done, guys. So if we want to prove that a triangle is isosceles, we have to prove that there are 2 sides that are equal, or how we would get to that is that there have to be 2 angles that are equal. Okay, but specifically, it's proving that there are 2 sides that are equal to one another. All right, so inside this triangle, we already know that R is equal to X. If we can prove that either W1 is X or that V1 is X, then we can prove that there are 2 sides equal to each other because they would be the sides opposite equal angles. So what do you think? Where are we going to go with this? That's it, Tsegofatso, you've got it. Your geometry is really lovely. Good. Let's just see if everybody else can see it as well. Okay, so Tsegofatso has already said the answer. Can the rest of us see where this would go? Remember, you've just proved that the quad is cyclic. Hint, 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 hint. You've proved that the quad is cyclic. You're going to use the fact that this quad is cyclic in this bit. So Tsidiso, let's just see what you said. Angles in a triangle. There you go. Yes, Tsegofatso, you're quite right. That's it. Okay, where's the cyclic quad into Kozo? Where's the cyclic quad? Oh, okay. You mean the one that we've just proved? Okay, so the exterior angle would be W1, what's that equal to? It's equal to angle T, but we don't know anything about T. So what they want you to do here, guys, is they want you to say that now W2 is equal to X. Okay, because W2 is equal to S2. They are angles in the same segment now that we have proved that the quad is cyclic. So W2 is equal to X, and W2 is equal to V1 because they are alternate angles. Can you see that? Okay, I know Tsechofatso can see it. Can the rest of us see it now too? W2 equals S2. Okay, because they are angles in the same segment. And S2, sorry, W2, I beg your pardon, W2 is equal to V1 because they are alternate angles because of the parallel lines, WT parallel to RV. Okay. And we've said that angle R is equal to X. That was proved above in 1.2. So this means that V1 equals R because they both equal X. That means that WR has to be equal to WV because they are sides opposite equal angles. Okay, so therefore triangle WRV is isosceles because there are two equal sides. Okay. All right, so just going through it one more time, Kalipa. All right, we've got angle, let's use a different color. We've got angle S2 that's equal to angle W2 because they are angles in the same segment. W2 is equal to V1 because they are alternate angles. They make a Z shape. And V1 is equal to R because they're both equal to X. Thus, the sides opposite those angles are equal to one another. So side WV is opposite angle R. Side WR is opposite angle V. And if we have two sides of the triangle equal, then it means the triangle is an isosceles triangle. Okay, so that is a little bit more difficult now. That was out of 4 marks. Okay, Kalipa. Sometimes when there's lots of steps, it is very easy to get lost. Okay, so we have to make the connection to S2. We have to make the connection to V1. We have to state these two angles that are equal to one another, and then those sides and the reason sides opposite equal angles. Okay. All right, let's try question C now. This should hopefully be a little bit easier because they've told us which triangles to work in. So when they give us the triangles, that's always a little bit easier. So let's do, just thinking if we could squeeze it in up there, but I don't think we can. All right, so 1.2C, they want us to work in triangle WRV. So we've got that triangle highlighted already. And the other triangle they want us to work in is TSV. So triangle TSV. So let's just highlight that for ourselves. Let's use a different color. Let's use yellow. And here's TSV. So they want us to prove that these two triangles over here are similar triangles. If they give you the triangles already, they are telling you which angles are equal to one another, right? Because they're giving you the order. So we know that W goes with T. We know that R goes with S. And we also know that V goes with V. So that gives us some nice clues to work with. So why is angle W1 equal to angle T? Okay, that's not immediately obvious. We can't start there. We can't start with angle sum and triangle. Okay, let's start with angle R. Angle R is equal to angle S2. We've actually already proved that, haven't we? There we go into causal. Perfect. Okay, so we've got point number 1. Angle R is equal to angle S2 because of tan chord theorem. We've actually already concluded that, haven't we? Good. Okay, angle V. So that would be V1 and V3. Why are V1 and V3 equal to each other? Because they are both equal to X. All right, so remember over here, we've explained why V3 is equal to X. And over here, we've explained why V1 is equal to X. So V1 equals V3. Both equal X. And remember, we just need 2 angles to prove it. We could always do the third one using angle sum in triangle. So angle W1 is equal to angle T because of remaining angles in triangle, or angle sum in triangle, but we're never allowed to use that as our first reason. Okay, it's got to be other things that come first in the first 2. Okay, never ever angle sum and triangle in the first 2. There we go. So we've done it. So that means that triangle WRV is similar to triangle TSV, and we've proved it by angle, angle, angle. Okay, so this is out of 3 marks. It usually is, and there's 2 ways that they can choose to mark this. Either they mark the first 2 and then the last line, or they mark the first 3 reasons. Okay, so either they mark it this line, and that line, or their alternative to marking this question is they mark that and that and that. Okay, probably the pink rather than the green, but those are the 2 ways that questions like that get marked. Is everybody happy with how we've proved those triangles are similar to each other? Any questions before we move on? No? All right, let's jump into it. So now we look at the next thing, and they ask us to prove that RV over SR is equal to KV over TS. Now, this is a tricky question. It's not a trick question, but it's a tricky question. And the reason why it's tricky is because when we are teaching similarity in class, every single teacher, doesn't matter where they are in South Africa, I'm sure they all do the same thing. We all teach you that once you have proved that triangles are similar to one another, you write down the ratios of the sides in proportion, right? So naturally, when we see a question like this that follows on the proof of two triangles being similar to one another, we immediately want to launch into WR over TS equals RV over SV equals WV over TV. Because usually 99.9% of the time, our solution to the next thing comes from that proportion, except in this case, it doesn't. Okay, so if you now write down the corresponding sides in proportion, it will not help you to solve question D. Okay, so this was the side swipe of this particular question. Now, we wouldn't know that in an exam. We would follow the normal procedure, and what we would find is we would get stuck. So what's happening here is similar in theory to what was going on over here. Remember in the beginning when I said to you CM over ME is what would it be equal to? Do you remember? I think it was you, Lebogang, and it really doesn't matter who it was. Lebogang said CM over ME is going to be equal to CG over GF. Do you remember that? And what happened there? It was true, but it didn't lead to a solution. This is exactly the same thing. So we can write the corresponding sides are in proportion. It's true, but it actually does not lead to a solution of this particular problem. So most people would probably try this, find they get stuck, and then probably become frustrated and not want to finish the question. All right, but when we get stuck, it's just a symbol or a sign to us that we haven't thought of another way. There's got to be another way that we can approach this particular problem. Okay, so I'm going to give you a hint, and there's two ways we can answer this question, but the first way is probably the easier of the two. If you look at RV over SR equals KV over TS, TS is equal to another side in this problem. What is TS equal to? We actually spoke about it in the very beginning. What is TS equal to? Aha. So do you remember, good Tristan, good Kalipa, TS is equal to TV. So your teachers would have also shown you that when you want to prove a particular proportion, we can replace a side with another side that it's equal to. Does that ring a bell? The replacing of sides with something that's equal. We've all seen that in class. Okay, so that's what this question was testing. Okay, so what we're going to do here is we're going to replace TS with TV. So we would end up with RV over SR is equal to KV over TV. So we've replaced our side. Can anybody remember now, how do we figure out which triangles we're working in? Do you remember the rules around that? How do we figure out from our proportion which triangles we're working in? Okay, Tsegofatso. You're on the right track. I'm just seeing what the others are saying. So if the rest of you can see that, Tsegofatso's put on SRV. Where did they get that from? Where did Tsegofatso get SRV from? Does anybody else know? Okay, so I just don't want us to run out of time here. Yes, with pleasure, Lebogang. So Lebogang, either we go across the top and across the bottom, or we go around the outside. So we look at the top and we say, is RVK a triangle? RVK, it's not a triangle. So across the top doesn't work. So that means now we have to go around the outside. Is it ringing a bell? Is RVS a triangle? RVS. Yes, it is. Can you see it's a big triangle here? Okay. Is KVT a triangle? Yes, it is. There we go. We've got it. Okay, so the actual triangles that we're now going to be working in, can I rub everything else off? I mean, obviously you would have your diagram sheet, but just to show you, I just want to highlight these triangles just so that you can see that a bit better without all this other gumph on the page. All right, and here we go. There is RVS, guys. Here it is in blue. There it is. There's RVS. And here is KVT. Ah, man, come now. And then they share that little bit of a side over there. You see it now. Okay, so if it doesn't work going numerator and numerator and making a triangle, if that doesn't make a triangle, then there's no point trying to make the bottom SRTV. There's no point doing that. Then go around the outside. Okay, so across the tops or around the outside. Now, remember, they're also particularly sticky about the way in which we start this question. We're not allowed to write this down on the page because that's what we're trying to prove. So they want us to start by working in the correct triangles. So we must begin question D by stating the triangles. So we've got in triangle SRV and triangle KVT. Now remember, we had a bunch of things that were also equal to X. That was equal to X, that was equal to X, that was equal to X. I think that was all. Okay. So let's see if we can prove that some angles are equal to each other. So can you see an angle in triangle SRV that's equal to an angle in triangle KVT? I can see one. This angle over here will be equal to that angle over there. Why are those green angles equal, guys? Okay, so it's got to be angles, Kalipa, not sides. It's got to be angles. That's it, and because they are alternate angles. So that can be our first point. Okay, so angle V, so it would be SVR. So angle SVR, or V1 plus V2, will be equal to angle K4 because they are alternate angles. Let's just move this over a little bit because KT is parallel to RV. Lovely. First one done. Nice. Let's go back and look at the diagram. Oh, I rubbed something off that's important to us. What's another reason, guys? Yes, Awami. So a side is a side and an angle is the space between the sides. Okay, so there's definitely a difference. You can prove triangles are similar using the sides though, but then you've got to know something about their lengths. Okay, we don't know anything about lengths of sides here, so that's why we've got to do it angle, angle, angle. So look here, guys, angle V3 and angle R are equal to one another because they're both equal to X. Do you see that? I had rubbed it off when I rubbed the other lines away, but angle V3 is equal to angle R. Remember that. Okay, so we're going to use that as well. Okay, so over here, angle R is equal to angle V3 because they both equal x. And essentially now we've done it, haven't we? We've proved that these triangles are similar. We can just conclude about the third angle. Okay, so that would be S1. So here, angle S1 in the blue triangle and angle T2 in the yellow triangle. So this is angle T2 over there, and this will be angle sum and triangle, or remaining angles of triangle, etc., etc., etc. Okay, so now we can conclude, therefore, triangle. Now, I don't know if your teachers did this with you at school. This is something that I always show my matrics every year. When I am proving two triangles are similar, and I don't know the order, it's not something that I have been given, I always write it in a specific way. So I always write the angles of this triangle down the left, and I always write the angles of this triangle down the right. And then it tells me the exact order. Okay, so I know that I've got my order correct. So angle V, and then angle R, and then angle S is similar to triangle K, and then V, and then T. Did your teacher show you that as well? I do that with my matrics every year. So now we've got the order correct. We know that we need to get this order correct because our next statement, the corresponding sides and proportion, is based off of that. So we've got to be able to get the order correct. It's very important. Okay, so now we can launch into VR over KV is equal to RS over VT is equal to VS over KT, because they are corresponding sides in proportion, or corresponding sides of similar triangles in proportion. Let me just double check myself. VR over KV, RS over VT, yes. And then first and last, VS over first and last. Cool. Now I'm going to go back. I want RV and SR. RV is here. SR is there, or RS is there. Then I want KV and TS. Okay, now I don't have TS, I have TV, don't I? But I know that TV is equal to TS. So now I can swap that out again. Okay, so now I'm going to say here that RV over KV is equal to SR over TV, but TV equals TS. Okay, proved above, or tangents from the same point. Again, don't have to say the same reason again and again and again. So therefore, RV over KV equals SR over TS. Do I need to do? Oh, and then there's just one last manipulation. RV over SR. Now what they want me to do, sorry, this question was a bit of a kicker, isn't it? Now they want us, so remember, we can interchange them like that. Okay, so finally I can conclude RV over SR equals KV over TS. Okay. Does that make sense to everyone? This is a tough, tough, tough question. Okay. So guys, if that was a little bit fast, sorry, I'm just rushing because the end of the lesson is coming. Come back and watch this again. You don't have to watch the whole video. Just fast forward to this point, and then maybe just watch this last part again if you want to. Okay, but it should be based off of things that you've seen in class, heard in class. It's just obviously there's a lot of points here for us to consider. Okay. It's only out of 4 marks, Tristan. Look at that. It's out of 4. Okay, so what would be important here is obviously proving the correct triangles are similar to one another. Maybe in this case, there would have been 1 mark on that and 1 mark on that. There obviously has to be a mark on your proportions together with your reason. I would say here there would have to be a mark for showing the TV and TS. No, there can't even be because that's out of 4. So maybe not even that. Where would the 4th mark come from? Because I mean, they're not going to give us a mark on this, are they? And they're probably not going to give us a mark for interchanging it. So maybe getting to that point, RV over KV equals SR over TV. Okay. That's fine, Segofatso. So now there is actually another way that you can answer this question, but unfortunately we've run out of time. But just if you are interested and you do want to come back and have a look at it, you can also use proportionality intercept theorem and work in the blue triangle. Okay, because you've got side WK that's parallel to RV. So it is possible to do it that way as well. But unfortunately, I don't have enough time to be able to do that now with you. Okay.